Good morning and happy Monday. It is Monday, November 16th. You're going to need to be in your year view for today if you don't make it to class and get the notes. So make sure that you watch this video. We're going to be in forces in motion. We are on checkpoint 2, which is technically checkpoint 1A, balanced/unbalanced forces and net force. So you're going to want to open this up. And we're going to be going over the definition of balanced forces, unbalanced forces, and the definition of net force. And then we're going to do some practice with calculating net force. And that is what the plan is for today. So, unbalanced and balanced forces. So, an unbalanced force is unequal forces that cause changes in motion. So this is an example of an unbalanced force. We've got people playing tug of war. We have this guy over here who's got 100 newtons of force. And these two guys over here who have 200 newtons of force. These two people have more force. There's more people. They're going to win. They're going to be stronger. They're going to have 100 newtons on these other people. So it's going to move. The rope is going to move to the right. Okay? So when the definition for unbalanced force, make sure that you put an unequal force that causes change in motion. A balanced force is two equal forces acting in opposite directions on an object, but balanced forces do not change the motion of an object. So if we've got three people playing tug of war here in this example, 350 newtons pulling to the right, 350 newtons pulling to the left, there's not going to be a change in this motion. It's going to stay right here in the middle. It's going to be a stalemate. So make sure you put this in the correct balanced forces box. Net force, this is the total amount of forces acting on an object measured in newtons. So again, that is going in this box. All right, so a little bit of practice. It says find the net force. So when we're finding the net force, we are going to be adding or subtracting to make sure we can figure out what the net force is. So if we've got 50 pulling to the top, 50 pulling down, 50 and 50 are going to cancel each other out. So the up and down motion is 0. That's a balanced force. It's not going to move up or down. We've got 30 pulling to the right and 30 pulling to the left. Again, 30 and 30, it's going to cancel each other out. So that box is going to stay put and not move anywhere. Okay? So the net force would be 0. Then we have this little shopping cart. We have 5 newtons pushing to the left, 5 and 9 newtons pushing to the right. Sorry, it's pushing to the right. So what I would do is I would add 5 plus 9, which would give me 14. So I have 14 newtons that are pushing to the right. So I would set up like a little T-chart, like so, left and right, and I would have right is 14 newtons. And then on the left, I would do 9 plus 2 plus 3, which is, again, 14 newtons on the left. So 14 minus 14 is going to be 0. So again, that is a balanced force, and it's a 0. It's not going to move. Now, find the net force of this little guy. So, pushing to the right, we have 20 newtons. 20 newtons. And on the left, we have 60 newtons. Okay, so 60 is larger than 20, so I'm going to subtract 20 from 60, which gives me 40 newtons. So this is an unbalanced force, and it's going to be 40 newtons to the left. So it's going to go, well, the box is going to go that way. I had to figure out which way the correct arrow was going to go. All right. That is what we talked about today in class. If you have any questions or concerns, please email me, and I will see you later.